Hello, today's lesson is on solving two-step equations. So we are going to look at how do we solve equations that involve two steps. So firstly, a two-step equation has two steps in order to solve the equation. We have two goals when we are solving these. We are aiming to have the variable on one side of the equal sign and the constant on the other side, and our second goal is to get the variable all alone. I want you to remember that the constant really is like your answer to the problem. That's what we're talking about. There are just a few other things that I want you to keep in mind as we do these problems. If we take a look at an equation that looks like this is our first example, 2x plus 1. I like to call the 2, which is the coefficient of x, the bestie. So, like your best friend who you hang on to the longest, that's your bestie. And then we're going to call the part that we're adding on or subtracting on, anything that has that another operation, as the acquaintance. And you want to get rid of your acquaintance and hang on to your bestie. So hang on to your bestie till the very end. It's just a fun way to try and remember how you solve two-step equations. The other piece that I want you to remember is that you are so good with GEMDAS, and we use reverse GEMDAS, so in reverse order, to go ahead and solve two-step equations. So my first two-step equation example is 2x plus 1 equals 9. And I'm going to follow the steps that I have in this section right here to guide me. My first step is to go ahead and box the variable. So I'm going to make a box around the variable. I'm going to then go ahead and undo any addition or subtraction. So I see that 1 is being added. That's the acquaintance. I'm going to get rid of it. So I'm going to subtract 1. And whatever I do to one side, I must also do to the other side. When I do this, the positive 1 and negative 1 cross each other out. They make a 0 pair. And I'm left with 2x simply on this side. And that equals 9 take away 1 is 8. Now this means 2 times x. So I've already boxed the variable. I've undone the addition or subtraction. And now I'm going to undo multiplication or division. 2x means 2 times x. So I'm going to do the opposite operation of that, which is divide both sides by 2. So I just did undo of multiplication or division. Well, 2 goes into itself once, leaving me just with x, and 8 divided by 2 is 4. So I'm left with x equals 4 as the solution. So the solution is that. I'm missing step 5, which I think you should include in your notes page, so which is do a check. And this is how we do a check. To do a check, we use the equation that was in our original problem, which was 2x plus 1 equals 9. And now I'm going to plug in my value for x, but I want to remember to plug that in using parentheses. So I'm going to do 2 times the quantity 4 plus 1 equals 9. It just will help you prevent making careless mistakes if you use parentheses. 2 times 4 is 8. 8 plus 1 equals 9. And 9 does indeed equal 9. Check, I'm set. So that's how we do this first problem. Let's take a look at a different problem. Now I have, for my example 2, negative 3x plus 4 equals negative 11. Again, I'm going to follow the steps. My steps are to go ahead and box the variable. So I'm going to do that. I'm going to go ahead and make a box around the x. So I've just done step 1. My step 2 is to undo any addition or subtraction. Well, the 4 is being added to the variable. So I'm going to do the opposite of that. I'm going to subtract it. If I subtract from one side, I also need to subtract from the other, which leaves me with negative 3x equals negative 15. So I just did the undoing of addition or subtraction. My next step is to undo multiplication or division. I have negative 3 times x. The opposite of multiplication is division. Therefore, I'm dividing both sides by -3. So make sure you grab that sign. -3 goes into itself once. I'm left with x equals a negative divided by a negative is a positive. 15 divided by 3 is 5. So x equals 5 is my solution. So I undid the multiplication or division, I did solve, and x equals 5 is what I came up as the solution. Remember, I need to do step 5, which is a check. And I'm going to do that off on this side. Here's my check. Remember, I'm going to use parentheses to input my value for x. So I have -3 times 5 plus 4 equals -11. -3 times 5 is -15 plus 4 equals -11. And -15 plus 4 is -11. And -11 does equal -11. Check, I'm done. That's perfect. So that's how I would do example 2. And let's take a look at one more example on this page. It's example 3, which is x divided by 3 plus 1 equals 10. So I've got x divided by 3 plus 1 equals 10. Remember, it's helpful also if you say the problem out loud using operations, just like I did, saying x divided by 3 instead of x over 3. It helps you register what operation is going on. I'm going to box my variable. So here's my variable getting boxed. And I'm going to get rid of the acquaintance first. So anything being multiplied or divided by the variable is the bestie. Anything that is being added or subtracted is the acquaintance. So that's the part I need to get rid of first. So that's the acquaintance. And then this was the bestie. So I'm going to get rid of the acquaintance first. So let me rewrite this problem. I have x plus 3, divided by 3 plus 1 equals 10. I'm going to start by subtracting 1 from both sides. So get rid of that acquaintance. Goodbye. You have to leave the party. And then the bestie is left behind. So I have x divided by 3 equals 9. Now I'm going to, again, I'm aiming to get x by itself. So I'm going to multiply both sides by 3. And when I do that, the 3 goes into itself. I'm left with just x equals 27 as my solution. Now I should do a check. So I'm going to come here. There's my solution. I'm going to come here and do a check. So for my check, I'm using the original problem, x divided by 3 plus 1 equals 10. Remember, I'm going to input the value of the variable using parentheses. So 27, the quantity 27 divided by 3 plus 1 equals 10. Well, 27 divided by 3 is 9. 9 plus 1 equals 10. And 10 does equal 10. Check, I'm done. So I did find that x equals 27 was the solution for this problem. All right, we're going to take a look at a very special case for the next problem that we try. I'm looking at example 4. Right here, I'm going to put a star next to it because this is a very special case. The reason why this is a very special case is because in this case, I have x, the quantity x minus 4. So this whole part is 1 unit together. All of that being divided by 8 equals 2. So technically, there are invisible parentheses around this, which are not there, but I encourage you to write those in. So anytime I have something like the quantity x minus 4 divided by 8 equals 2, I should go ahead for these kinds of problems and go ahead and put parentheses as my very first step as something that I would do. Remember, we are going in opposite GEMDAS order. So we are doing reverse GEMDAS. And by putting those parentheses in, we actually have created the grouping symbols, which we will take care of last. So unlike the situation where anything that I was subtracting or adding from the variable was an acquaintance, in this case, it's not an acquaintance. It's actually a bestie because it's contained in the same grouping symbol together. So I will not be getting rid of the subtracting of the 4 first. Instead, I'm going to still box my variable. So there it is. I'm going to undo multiplication or division in this case. So I have the quantity x minus 4 being divided by 8. Well, I'm going to take that and multiply both sides by 8 to begin with, because 8 goes into itself, and I'm left with the quantity x minus 4 equals 16. I actually don't need parentheses anymore, so I am going to rewrite this and drop those off. And now I can go ahead and add 4 to both sides. And I find that x equals 20 as my solution. I can do a check to see if I did indeed do this correctly. And if I did it correctly, things would work out well. So I have x minus 4 over 8 has to equal 2. I'm going to go ahead and input the value for x in parentheses like that. Plug that in using parentheses. Over 8 equals 2. Well, 20 take away 4 is 16. Over 8 equals 2. 16 divided by 8 is 2. 2 equals 2. Check, I'm right. Now, just for fun and just to prove that we have to be careful the way we do this, I'm going to do this problem incorrectly in the margin right here. So let's say I have the problem x minus 4, just like the problem we have, over 8 equals 2. And if I went ahead and added 4 to both sides first to get rid of this 4, so let's assume that I decide to, oh, you know what, I'm going to add 4 to both sides because that's going to make these go away. I'm left with x over 8 equals 6. Then I would be multiplying both sides by 8. So this is, by the way, the wrong way. I'm just going to prove to you that if you do it the wrong way, it doesn't work. So if I added 4 to both sides, I end up with x over 8 equals 6. And now to get rid of this 8, I would multiply both sides by 8. 8 goes into itself, and I'm left with just x equals 48. Well, let's do a check to see if x equaled 48, does my equation work out? So if x equaled 48, I would be saying 48 minus 4 divided by 8 has to equal 2, because that's what my original problem was. There's my original problem. If I check this, I find that 48 minus 4 is actually 44. And so 44 divided by 8 has to equal 2. If I multiply both sides by 8, I end up with 44 has to equal 16, and we know that's not right, so that's not correct. I've gone wrong somewhere, and I know exactly where I went wrong. I needed to create grouping symbols to group the parentheses, to group the numerator together, because this fraction bar extends over the entire numerator. Okay, so we have to be really careful about these special case situations.